There are 5 YCS domains. So as far as like standards go, the first one is computing systems. I think people kind of take for granted how many computing systems are kind of around them all the time. Like for instance, my dad just sold a truck where it doesn't even have like roll down windows. You had to like crank the window down. And then all of a sudden he's buying a car that like can tell, so it follows the car in front of you, so you can set like the speed control to like 75, but if you come up on somebody, you don't have to turn off and on your cruise control. It'll just slow down to be like a safe distance from that car until you turn on the blinker, and then it'll like go around them at 75 or whatever. So it seems like, I don't know, it seems like sometimes we take them for granted because we're using them to solve, you know, more and more complicated tasks, and then in the meantime they're becoming more and more like commonplace.
Yeah, right. It's in all aspects of life, I guess, at this point.
Jessa, do you want to talk about the like Instagram algorithms and stuff like that?
Yeah, basically the whole thing with the Instagram's algorithm is it takes your like previous likes and like who you follow, and then gives you like, I guess, recommendations on like, oh, if you like this, you should follow this person.
Awesome. So another one is like networks and internet. Fiona, do you want to talk about some of the stuff you did with DDoS attacks?
Yeah, sure. So I chose this topic because cybersecurity attacks are increasing a lot, and especially DDoS attacks are increasing a lot day by day. Recently, I think Amazon had the biggest DDoS attack. So what's difficult in detecting DDoS attacks is that it's easily evolvable, and the attack vector can change very easily. And nowadays there are hire for DDoS services, which makes conducting the attack easier, I guess. So that's why I decided to use like deep learning to create like a solution so that people would be able to detect DDoS attacks in the future.
Yeah, super important for network security too.
Yeah, do you need to apply the deep learning onto the graph data?
Yeah, which actually, funny enough, brings us into our next point, which is like data analysis.
Data analysis? Now, currently I'm focused on research apply the deep learning onto the graph data, because graph data is different with the structured data. They have some relations between the data. So I'm starting to do this work.
Yeah,
it's very interesting, I find.
Yeah, so you're talking about like graph databases with like nodes and edges versus ones that are like in like a SQL database. Is that what you're talking about?
Yeah, such as social networks. Each node deloads one person, and 2 persons, maybe they have some common features like this.
So we're in like a traditional database. It's easy to say, okay, like here's my table of like women in computer science. Here's my table of people interested in network security, right? It's a little bit easier when you've got like, you know, the people are the nodes, and then they're connected to different other types of nodes that are like, oh, this actually indicates like this person's interested in all of these things.
I've recently been working with a lot of like social networks and things. With that data, it's very large. There's kind of a lot of issues with running certain algorithms that don't take hours and hours to run. If that even, like sometimes it's not even possible to get solutions to certain problems at all. And so I guess one area of my research is determining like which problems are actually possible or not. And with that, you can kind of determine the way you want to approach the engineering of your algorithm. And so it's been really interesting because you can improve like certain properties about certain problems. So like, I guess one example with social networks would be, like you said, Shay, like determining who is most interested in certain things. So like you can prove whether that's actually possible to find or not exactly. And then if you can't find it exactly, you can approximate it.
Yeah, or like you could find it exactly, but it would take like the rest of the Earth's life.
Yeah.
We do calculations.
Yeah, exactly.
Yeah, we actually, in one of my classes, we kind of did that with like the traveling salesman problem. Like we made an approximate algorithm and then like an exact. And like for the exact one, it took like, I don't know, like 5 nodes or something until like it took over an hour to run the algorithm.
It's actually kind of the perfect segue once again. I don't know how you guys keep doing it, but like algorithms and programming, you know, coming up with like efficient algorithms to actually like solve problems, I think is incredibly important, because there's a difference, right, between solving a problem perfectly and solving it good enough.
In my opinion, the finding approximate solutions, that's a big area of kind of what I've been working on, and it's really interesting because you can kind of like bound the approximate solution, basically, like it's only this much worse than the exact solution would be, even though it runs in like half the time or whatever. And so you can kind of chip away at that upper bound, basically.
Especially since there's so many ways to solve a problem, and then you get into these weird discussions like, well, mine runs, in 5 minutes, but I get 100% accuracy, and somebody else is like, well, I only get 98% accuracy, but mine runs in 2 minutes, And I think that there's some use cases there where it's like sometimes you need the accuracy. Like if you're launching a space shuttle, like who cares how long it takes to run your final checks, right? They better be right.
Yeah.
Awesome. Impacts of computing.
I don't know. Especially when you're younger, it's like everyone is on their phone when they first get it, I guess. I feel like that's an impact socially, I guess, or like social media is like a good way to connect with, I don't know, people you can't see in person.
Yeah, well, I think that's a huge impact of computing too, is just how flexible it makes us. You know what I mean? Like if we didn't have computers okay, good example, people who live in Wyoming but they don't have really like stable Wi-Fi, right? Like they're going to struggle getting work done right now. Whereas somebody who lives like, in town or even like a bigger town, right, who have stable Wi-Fi and stable connections to the internet, right, they're going to have a much easier time. So, I mean, I could only imagine if COVID came out, like 10 years ago, how different it would be. I mean, I don't know if we'd get much work done at all if nobody had internet and nobody had like connectivity or
dial-up.
Or dial-up.
That was horrible.
That's best answer of the day so far. But all about dial-up. Oh my god. You're right, that was a thing.
Yeah. We've come a long way.
All right, everybody. Let's all take a moment of silence for dial-up. All right, that was long enough.